Hello everyone, how are y'all doing? Pretty well. This is actually my first conference, so pretty excited to present in front of you all. I am today going to talk about full stack blockchain development. And I thought the best way to go about that would be to just build a full stack app together. So that'll have 3 stages, I would say. Like the first stage would be just spinning up a local Ethereum node. So that's what we'll do first. And then after that, we'll together write a very simple smart contract using this cool IDE that the Ethereum Foundation put out called Remix. And we'll deploy that to this local node that we spun up on our own computer. And afterwards, finally, we'll get to the React front end. I won't do any live coding on the React front end because you all are React experts. No need to talk about controlled components and code it. So we'll just wire it up and see some smart code, smart contract states get changed. So let's get started. So this is I'm just calling this a single message. As you can see, there is something in here called the Genesis JSON. Every blockchain needs to start somewhere, right? The first block is called the Genesis block. So all right, let's use that. Let's use that to initiate our blockchain, and let's store it in a directory called chain data. So let's see. All right, cool. That was it. That's all it took to initiate a blockchain. So afterwards, let's see. Let's create an account in here. So here's the chain. Let's create a new account. And let's just give it a very visible password here. Very complicated. All right. Cool. So that created an account on the local Ethereum private node. An account is essentially, you can think about it like a place which holds your money and allows you to interact with the Ethereum network. So that's what this is. Cool. All right. Now let's power that up. So when we're doing this, we'll expose something called the Rpc endpoint. This is essentially an HTTP RCP endpoint which allows the HTTP protocol to talk to the Ethereum blockchain. Let's also make sure that let me spell this correctly. Cores domain. Let's make sure any website can talk about it without any cross-domain concerns. Also, let's unlock our accounts. So accounts hold money, and by default, they're locked. So for development purposes, I just unlock it. So to do that, we just pass it in the same password we passed it on before. And then let's unlock the first account. We only have one. And yeah, that's all it took. Right now, this is your blockchain is running. So a couple of things I would like to point out is the unlocked address is right there. I don't know if you can see my mouse pointer is quite visible. Cool. So here's the HTTP endpoint that we'll be using to wire up the React application. But for now, let's get a miner running. So for that, I need this. Ooh, whoops. For that, I need to copy this. Cool. OK, let's get another. It's very small. So let's attach a JavaScript console to this. All right, cool. And now let's just start a miner. Cool. Now we have a Ethereum node running and mining happening on it. So the next thing I said we're going to do is write up a smart contract. And this is the Remix tool. I'll give a quick overrun about this, and I'll talk a little bit about Solidity as well, which is the programming language used to write smart contracts on the Ethereum blockchain. Solidity compiles down to bytecode, which is what is run on the EVM, Ethereum virtual machine, which is a 32-byte stack machine. Bytecode is hard to write and read, so that's why Solidity exists. So let's get right into it. So the first thing we need to do to Solidity is like tell them, in a Solidity program, is tell them like what version of the compiler we're going to use. In general, what I'm doing right here is actually not the best security practice. Writing Solidity requires a little bit of a security mindset because it deals with money. Ideally, like what people would do is like not have this caret, but specify a exact compiler. But for the sake of a presentation, we can just go with this. And let's write a contract. And I'm going to call this contract single message. So yeah, this is how you write a contract. A contract is essentially like a class. You can think about it like that. So once the contract is written, you deploy instances to it into the blockchain. That's a good way of thinking about it. And contracts have state variables. So let's write one. Message, because yeah, this is a message, a single message app, right? Smart contract. So what I did here, Solidity is a typed language. So this is a string. And then the next thing you see public, it's a visibility setter. So this is a public state variable. And once you set public, one thing Solidity does on the background is it sets a getter method. So if I need to get the method, if I want to see the message of the smart contract, all I would have to do is call the message function, and it'll give me the message in it. Great. So let's try a constructor out. So you can see like the name of this is the same as the contract. That means this is a constructor function. It'll be executed only once when an instance of the smart contract is deployed to the blockchain, Ethereum blockchain specifically. So let's like say, what should we say? Hello from the Ethereum smart contract, sure, right? That's what we're doing. And great. And so the only other functionality I'll have in this very simple smart contract, I only have 20 minutes to do this also, just set message. So let's just change the state of this, right? So we'll do new message. And public. And this is very simple code, just new message. A message is equal to new message, right? Cool. One of the things I really like about Remix is it allows for testing just in the browser. So let me show how that goes. So start to compile, let's compile it. All right, that's fine, that works. And then you can go here, the environment, right? JavaScript virtual machine, what this does is it spins up a very lightweight blockchain on your browser. And you can test if this contract is behaving the way you want. So let's test it out real quick. OK, let's get the message. All right, hello from the Ethereum. So that's fine. And then let's say hi. Sure, why not? Hi one. We can set that. And then, OK, all right, it's working, right? Pretty cool. And now we're going to connect up Remix with the local blockchain that we have running on our computer. And to do that, all we have to do is change this to the Web3 provider right here. And you'll see over here, are you sure you want to connect to an Ethereum node? This is saying, suppose say in case you connect to a test node or the mainnet, are you sure? So it's a good warning to have. And then you can give it the provider endpoint. Like I mentioned, the HTTP RCP endpoint that I showed when I was spinning up the geth node. The Ethereum node, geth is a Go implementation of an Ethereum client. This was the endpoint, right? So I say OK. And then you can see an account over here. And if we go back over here, we can just look at our accounts. And you'll see like this 83FE, 83F, blah, 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 28A. It matches up. So this is connected indeed to the blockchain that we spun up. And now let's say create. And something cool happens here. You can come over here and see like, this is so large. Let me make this a little bit smaller so I can find that. Let's see, here it is. So I just submitted a contract creation transaction, which essentially that means you send a transaction to the 0th address on the Ethereum blockchain, and that creates a contract for you. And the contract contains the bytecode that we wrote in Solidity. It got compiled to the bytecode, and it gets put into the transaction in the data field, and ta-da, voila, we have a contract. This address is really important to note, so let's save that, right? Because we want to talk to the smart contract. It's living in the world of blockchain. How do we do that, right? Cool. And now we can wire up. What have we done so far? We have spun up a local Ethereum node. We've written a simple smart contract, and we've deployed it to the Ethereum node. And now we need to just play with the smart contract, right? And this is where React comes in. So I'll show, can this be seen? Make it a little bit larger. So a couple of things. Web3, right? Web3 is the way React talks to the Ethereum blockchain. So I'll show a little really like how simple this actually is to do. One of my purposes, by the way, for this talk is to just essentially present the bare essence of how do you develop full stack blockchain applications, and then encourage people to just play with it. Like blockchain has a lot of promise, to say the least. So it will be good if more and more people can just jump on and see what's up. So all we have to do this is this line. This is the secret sauce. See, this line essentially tells, hey, create a Web3 instance, and the string over here is the provider. Like it's saying, hey, the blockchain that we want to interface with is at this string, this remote, right? All right, that's what I'm going to just export this. Web3. Cool, not too hard, huh? And then now I want to connect up with the specific contract, the contract instance that I deployed to this blockchain. So let's import Web3 from that file we just made. And remember, I was mentioning that address is really important. This is where it comes in. We need two things for a React frontend and any frontend, really. Actually, it can just be vanilla JavaScript as well. We need two things, and those are the address. So where in the huge space of Ethereum blockchain is this contract living? And how do I interface with this contract? Those are the two things. The interface is called the ABI, the Application Binary Interface. And we'll get that next. So let's see. Const ABI is equal to, what is it? Where can we find this? Turns out Remix is really cool. You can just go to compile, details, and it's right here, just hanging out. We can just copy that, come over here, and paste it. And we have the two things we need. And now in one simple, can this be seen? Now in one simple line of code, we're just going to create an instance that connects with this. The first property is the ABI. The second one is address. I guess I have to mention the Web3 versioning over here. I'm using Web3 version 1.0.0 beta 0.26. The reason I'm being so specific about that is because Web3 breaks all the time. And the only other, it's in rapid development and not stable. The other API, the version that's really popular is 0.2, and then just put numbers on there. Very popular. So, all right, cool, and this is it. We just connected it up, and I didn't want to live code React code because this is too simple for this audience. So I would like to just draw your attention to a couple of lines, level number 2 and 3, where I imported Web3 and I imported the deployed message instance. And then in the component did mount, you can see that there's a property called methods, and the methods has some methods called message. And you have to invoke it, and then you call it. Call it essentially is just read some data. However, let's see if I wired it up correctly, right? Like, what if I made some typos? Oh, this is so tiny. All right. Cool. Let me just start. This is just a simple create React app thing. So, moment of truth. Let's see if it worked. Oh, here we go. And now we have a hello from the Ethereum smart contract. That's what we wrote, right? Pretty chill. And let's see if it's working. Hello, test. Cool. You might have noticed like there's a wait, right? Like what's happening here? Let's like actually like dig into that a little bit because it's kind of important. So okay, now I'm here. I'm going to stop the miner, right? And now I'm like, hello from Reactathon. I wonder where that is. Cool. Oops. All right. Can anyone guess what's going to happen when I press submit?
Nothing.
Nothing? Nothing's going to happen? Is that true? Let's look. Let's take a look. What's happening? What's at the end of this log? Yeah, nothing. Like the transaction just sits. It needs to be mined. So this is where a lot of complex thinking enters the space and a lot of math. It's really quite exciting. So essentially, like yeah, I know, right? Like lots of stuff. Mining. What is this? It's essentially to get consensus on a distributed network. This is not a simple problem. It's been around for a while, and yeah. I'll leave it at that. I know it's a bit out of the scope of this conversation. But essentially, to change the state of a blockchain, it needs to be mined. Ethereum blockchain specifically. There's also miner-less blockchains. To change the state of an Ethereum blockchain, it needs to be mined. And once your transaction is mined, the state is changed. And voila. But let's see what I'm saying is true, right? Let's like start this miner and see if it works, if that's exactly how it works. Okay. Hello from Reactathon. Cool. Thank you. That's all I have for you today. And if you like this topic, Frontier FS is going to be talking about this for a whole 2 days. Please check them out. And yeah, if you have any questions, just be in touch. I'm online at these two spaces. Thank you very much for your time.